Okay, good morning, everybody. Welcome to day 3 of the Marine Mammal Commission 2025 annual meeting on emerging technologies to improve efficiency and support innovation for marine mammal stock assessments. We've had 2 great days, which we'll hear some about from our upcoming panel. But today our focus is on some regional updates, hot topics in the California current ecosystem. People have been here all day. We have emergency exits out the back of the room, trash cans, keep the lids on your coffee. We're in a beautiful facility at Scripps Institute of Oceanography. And I will remind folks as we start again today, this is a public meeting. Under applicable law, the Commission is required to maintain and provide a public record of the proceedings. And after a while, you can go to our website. The meeting's being recorded and will be posted there. As we start today, I want to introduce Karen Forney of the National Marine Fisheries Service, who's going to lead us on our session on hot topics in the California current ecosystem. So you're on, Karen. Thank you.
Thank you, everyone. Let's see if I can do this without breaking it. I think Brady gave me the rundown. I'm trying to just get it to start from the beginning.
Oh, sorry.
You could just start on this one here. How will we know it's working? Okay. Oh, is that the problem?
I'm wondering what happened, because we're doing the thing again.
Yeah. I didn't touch it.
No worries. Oh, wait.
I minimized the other one. Is that a problem?
Here we go.
Okay. All right. Thank you. Well, first of all, I just want to say it's such a pleasure to be here with everyone, and I so appreciate everyone at the Commission, all the staff, the CSA, the commissioners, and all of the contributors to the presentations and the members of the audience. It's just really such a wonderful forum, and I always enjoy it. And so I'll be moderating the session on regional hot topics in the California current. But I wanted to start, I was asked, actually, I was in the field and asked to moderate and didn't have time to deal with it. So I said, how about if I just do some thoughts on everything we've heard over the last 2 days on the fly? And Jackie and Robin were more than happy to accept that. And then as I got closer, I was like, what did I do? Oh my goodness. So I prepared a few slides yesterday just with some thoughts, some of my own thoughts about what we've heard over the last couple of days. And I hope they can be stimulating and informative, or if we want to have debates later, we're happy to do that as well. So my first take-home message is these were absolutely amazing, fantastic presentations. I was really in awe with not just the technology and how far we've come, but the individuals that have led the research, the innovation, the determination and efforts. We already talked about the efforts in the Gulf to keep all of those HARP arrays going, and Randy's perseverance with his remote attachment tag, and many, many others. And I was just so impressed with everything. I was literally sitting here just with my mind spinning about all the possibilities. So that just to start, that really kudos to everyone who was here and to the Commission staff who pulled together such an amazing group of people. And what I wanted to do then is step back a little bit and provide some thoughts from my own career perspective. I was on the ground floor when the 1994 Marine Mammal Protection Act amendments went through, and we started the whole way that we do stock assessment reports now. And so I wanted to kind of try to tie some of these things back as to how does it fit in? How can this augment our traditional assessment methods that we've been using for over 30 years? How can we improve the efficiency? And how can it improve our ability to manage these stocks effectively? And I will not have answers to all these questions, but I just wanted to offer some musings and food for thought best I can. So somebody mentioned this yesterday, maybe it was Jason or somebody, but really the bread and butter of our stock assessment is 3 components. One is we have to know the stock structure. We have to know which populations we're trying to manage. The other is abundance estimates, if we can get them. And if we have that and a measure of the human-caused mortality and serious injury, that gives us tremendous power to look at the many, many, many marine mammal populations and know which are the ones that we really don't need to be worrying about. And that ability, I used to call it triage, but that includes some dying, so I'm not going to use that term. But just that ability to prioritize is such a powerful tool, because really, from a West Coast perspective, really 80 to 90% of our stocks are in that category. And so that tells us if we can do these routine assessments and get just the basic, we have some stock structure information and we can get abundance and human-caused mortality at a reasonable interval, that is really powerful for knowing where do we need to be focusing more energy, and so that we don't waste our resources, or our always limited resources where they're not needed. And so that's a key part where I wanted to just focus and say, can these new technologies help us with this bread and butter? Because I think that is really step one in our assessments, is figuring out which stocks we don't need to be worrying about so much, and which are the ones that we need to really focus on. So I'm going to go through each of those three a little bit, and in green font are sort of my thoughts, my preliminary thoughts, and I won't be comprehensive, but preliminary thoughts on how these new emerging technologies can fit in. Stock structure, for starters, is complicated. It's very challenging to determine stock structure in these animals, and I have on the right an example. Harbor porpoise are distributed along the entire West Coast, from Point Conception up north and into Alaska, but they are not all the same. There are discrete populations, even though it appears to be a continuous or near continuous distribution. And we've learned that through a variety of methods. The most common ones are looking at distribution of animals, movements, if we can tag them or photo ID them so that we know their movements. Population trends may vary in different regions, telling you they're not actually the same. Genetic differences, genetic analyses have really been one of the most powerful tools we've used over time to identify that, and all of these harbor porpoise stocks have been determined to be genetically distinct. So we know that even though it looks continuous to our untrained eye, there are very distinct stocks. And there are a number of other methods that have been used, and I have a ... because that's not a comprehensive list, but thinking about the talks we heard, I think some of the tools for new telemetry deployment tools, ways we can get tags on animals that we previously couldn't to understand their movements better. The eDNA sampling, if we can, it's hard to get a sample from a harbor porpoise, but if you can take water samples and look at, is the harbor porpoise signature different in different regions, that can be informative. The acoustic data, one way of differentiating the population trends, if we can determine from long-term acoustic time series that there are different trends in different regions, that also tells us something either about population discreteness or differences in the habitat that they inhabit. And so I see great potential for a lot of these tools to help inform stock structure in ways that we haven't previously been able to do. And I think that's very exciting, because as Barb Taylor and colleagues have for a long, long time made us aware and reminded us, if we can't get the population structure right, we can't properly manage and conserve the species that we're charged with conserving. Secondly, abundance. This is where really the bulk of my work has focused, on West Coast stocks for abundance. And on the left side, we have the classic big white NOAA ship. This has really been the foundation of our stock assessment work. And we started in 1991 in anticipation of the 1994 Marine Mammal Protection Act amendments, doing these surveys, and they were great initially. We were able to do them every 3 to 5 years and get assessments for 20 plus species at a time. They're expensive, they're a big investment, but they were a very effective tool for really assessing all of the species in the ecosystem. And I do want to say, even though I'm really excited about all the new possibilities, I want to emphasize how important that has been as a tool, and that it really will continue, in my mind, to be a very important tool in the future, because especially some of the offshore species and the diversity of species that we can assess doing these large ship surveys, that's not something, we're not there yet with these new tools. So we may eventually get there. For some of the coastal species, we can do aerial surveys, especially pinnipeds at haulouts, or things like harbor porpoise and other species. And then for a number of species like humpback whales and blue whales, the small boat photo ID work, getting biopsies, photo IDs, has been just a tremendous goldmine of information on not just abundance, but also life history and movements and stock structure and you name it. So that's also a very powerful tool. And then on the right, we have for gray whales, we have the ground-based census that also can be appropriate in, probably limited, but in some circumstances. So this is kind of where we have come from with our, there's some other methods that I didn't fit on this slide, but these have been really the key ones. And I'm really excited about the prospect of some of these new methodologies to augment them. I don't think they will replace the need for some of these. So but they can definitely augment them. In particular, Tony's example of actually taking the walrus satellite remote sensing into an NMIN and using that in the stock assessment. I was so excited to see that, and hopefully we can build on that for other species that are amenable to that type of sampling. Also, the open source nature of the presentations and the programming and the processing that we saw from Kim and Kristen and everyone, that really, I think, is key to moving forward and helping this technology become available and useful for whatever species it might apply to. Obviously, we're not going to be seeing harbor porpoise from space. It's one of my species, as you could tell. But I think there is a lot of potential for some of the more visible species, and sharing all of that knowledge and trying together to find ways to overcome the cost of the imagery and working together, I think, is really a very powerful tool. So I was very excited to see that. Also integrating the acoustic and visual data. Kate showed very nicely how that works. Rob Schick's example showed how we can really use those to augment, and even though one data set may be imperfect or incomplete for a variety of reasons, by combining them and developing those analytical tools, we really have tremendous potential to enhance our ability to do abundance estimates. And this is particularly true given that the NOAA ships have been getting old and they have been getting mothballed, and ship time has become harder and harder to come by. And so our ability to do these surveys, initially we did them every 2 to 3 years, then every 5 years, then 8, and now it's basically almost a full-out brawl to get ship time to do these things. And as was mentioned yesterday, Jeff Moore in 2018 actually piggybacked on a fish assessment survey, which had some drawbacks from the marine mammal sampling perspective, but we're really trying to optimize. But the reality is that ship time is becoming more limited, and so having these alternate tools is really very powerful. The last one, the human-caused mortality and serious injury. I saw a number of tools that can help us potentially monitor injury outcomes, which is a big question mark. Our whole serious injury determination process has undergone multiple reviews, and there's always a list of things like, if we could do this, we could learn more type of questions. So I see potential for some of those, including some of the telemetry tools, if it's easier to attach tags to entangled whales to monitor what really happens, or the non-invasive blood sampling and metabolic sampling may be appropriate in some cases, and also some of these new analytical tools for assessing mortality and serious injury more accurately, like Jeff described. And these are all needs that we have, and I think the more these new technologies and new analytical approaches can help us, the better we will be able to assess marine mammal stocks and put our energy and efforts where it is most needed. I stole this slide. Actually, I asked Dave Johnston if he would share the slide, and he pointed me to the website where it's available. We talked a lot about this curve of, the expectations, and also we talked about validation. Like, how are we going to convince people that we really can see whales from space? And that other things that, we talked about, that they are valid, that there is good, that they're good enough, and so on. And I was thinking about this a little bit more, and I think the validation is really part of this slope of enlightenment curve. That, initially, oh, this is such a cool new toy, and they're like, yeah, that's never going to work. And then as we start to figure out how to make it work and realize that, yes, for these applications, it really does give us very valuable data, we can demonstrate that. And I want to encourage people who say, oh, we're never going to convince people, or it's too hard. That is actually where our ship surveys started. And on the right, I was hoping to find a filled out sighting form from the Southwest Fisheries Cruises. This is an unfilled out one from a long time ago. But even with the shipboard surveys, when they first started in the Eastern Tropical Pacific related to the tuna dolphin issue, there was a lot of skepticism that we could find the dolphins, that we could identify them correctly, that we could count them correctly. And we had to prove that. And so for decades, every sighting we have had on our West Coast surveys has had a sighting form with it where the observer has to draw what they saw to demonstrate why do you think that is a spotted dolphin or a spinner dolphin or something else. And also we had to do studies in association with those surveys in the 90s with helicopters to demonstrate that yes, the observers can actually estimate the number of dolphins out there reasonably. And so those doubts are around for all of our methods. It's just they're in the past for our traditional methods, but I just wanted to remind everyone that we had to do those same steps for all of the things we're doing now. So that's sort of the bread and butter of our stock assessments, and I do see great potential for some of these tools to contribute and enhance. But I also see a lot of potential, and I couldn't really, a lot of the talks are definitely outside of my field or expertise. They're super, super cool, and I wish I knew more, but I don't. So I'm just saying that all of these new tools and approaches seem like they have tremendous value for these species-specific deeper dives where we need to know more about, is there really a problem? Can we reduce the uncertainty in the assessment that we think there may be an issue with the abundance and the mortality? Can we identify causes of population declines or these stranding events and pulses that we have? Can we improve our knowledge of what's going on through health assessments and also examine cumulative impacts, as Leslie illustrated? And also some of the work that Kate presented with the habitat use from the acoustics. Can we improve our knowledge of how these animals are using the habitats and how that matters to our human activities and so on? And so there's just a tremendous amount of potential for these to really help us in the most critical cases where there are concerns about species, and I'm really excited about that. And again, I don't have like the exact connections and everything, but that's what all of you here are in the room for, and all of the brilliant people that work on these studies can do. So with that, I wanted to invite everyone to consider how all of these cool new technologies may or may not help us with some of the regional updates we have here in the California Current, the hot topics in the California Current. And we'll have 4 speakers. Elliot Hazen will speak about using climate-ready information decision-making for multiple stakeholders and really informing management in a very comprehensive and ecosystem-related way. Then we will have Ryan Bartling present on an ongoing, a very important process to assess and mitigate whale entanglements off California. Very collaborative approach again, multi-stakeholder involvement. We will have Amy Lang give an update on the status of Eastern Pacific gray whales, of the North Pacific gray whales that migrate past here. And then we will have Clarissa Anderson talk to us about algal blooms in California and how that's changing and what we know about it. So I'm very excited to hear these talks and also think about how some of these new tools might contribute. And I think I'm about at time, so if I can invite Brady up to lead us. I'd like to introduce, we have 3 remote speakers initially, and then Clarissa will close out the session, and then I believe, actually there'll be a break before Clarissa, and then after we'll have Clarissa and the discussions. So with that, I would like to introduce Elliot Hazen with his talk coming up. Thank you.
Elliot, it looks like you're muted currently on Zoom, but we did see you share your screen. It just wasn't in presenter mode yet.
Perfect. Let me try this again. Always technology to the rescue, as we've been talking about. Okay, now let me know if you can see the correct screen. It looks like not.
Correct.
There
Now
we
we
go.
can see the correct screen.
Perfect. Okay, thank you guys so much for inviting me and letting me talk. Oh, sorry.
Heads up, Elliot, we're now seeing a blank black screen. It did look like we had it up, and then it sort of, once you click continue to share or whatever, it disappeared.
Okay, let me try that one more time.
No worries. We have a nice virtual background.
Excellent. If this doesn't work, I have another potential way to do it. How about now?
That is correct. It looks great.
Awesome. Thank you so much. And I apologize that I cannot be there in person, but you will have to just listen to me. So I'm not presenting really on my work, but really a whole suite of work from a number of collaborators. And hopefully I'm don't have to convince you, but I still will try to convince you that really looking at these processes from multiple timescales can offer a better solution to management. And so in terms of just the basic kind of biology and ecology, we know that climate impacts species distributions such as large whales across multiple timescales. There's a great new study by James Fallbush, really near and dear to my heart, that is looking at how fine scale ephemeral features like fronts influence krill density, and then in turn, the appearance of blue whales in the California current. The marine heat wave scale acting on kind of the week to months. It's really one of the ways that climate variability and change combine to have direct impacts on our ecosystem. Climate change scale, where we're able to now, beginning about 20 years ago, start to forecast out into the future, or predict out into the future, how things are likely to change. And then this kind of medium scale, the 1 to 10 or 10 years, scale, is one of the most difficult to predict physically. So it's one we're still working on, and is not one I'm going to talk about much in this talk. But the same way that we know animals respond at multiple scales, the management decisions do as well. If you're thinking of things like vessel speed reductions, you may want to have very fine scale, turning on and off when there's high densities of whales presence. Things like fishing zone closures can also be at the shorter scale, but can extend to things like weeks to months, depending on how long aggregations are predicted or are likely to persist. Longer scale, decade to century, if you're doing things like protected areas, you want to make sure they're not just in the right place now, but they will be in the future as well. And then things like semi-permanent structures for wind energy, et cetera. And then again, this year to decadal scale, also the permitting opportunities for things like seismic Navy activities, or in the case of fishing, whether a fishing vessel is going to invest in a license for a given year, given there might be increased risk, is the kind of thing we could inform at these kind of medium to long-term scales. So then I'll talk about how we can use models to create accurate predictions of whale distributions across these scales to support climate-ready decision-making. And I'll say it now, and I'll say it again at the end, but what I'm presenting on, again, are models, and the models are only as good as the data that go into them. So none of this is meant to replace data, but it's hopefully another tool we can use to augment it. So 3 California case studies. We'll talk about some nowcasting work on marine heat wave impacts in the California current by Heather Welch. Then seasonal forecasts of marine heat wave impacts that Steph Brody published. And then last, I'll just end with some projections of long-term warming impacts that we did in collaboration with the West Coast Marine Sanctuaries. So jumping right into it, for heat wave impacts, the North Pacific is an ideal test bed. We've had a number of recent marine heat waves, and if I were to add data, we'd still be in a marine heat wave condition right now. I'm sure you guys are experiencing the warmer temperatures right now in La Jolla as we are in Monterey. So with that, we're able to fit long-term tagging data from Oregon State University with the underlying oceanographic conditions, and then predict where these animals are likely to be in these 4 marine heat wave scenarios. So again, the inferences I'm presenting are from models as opposed to direct observations, but we use the direct observations to validate throughout the process. Again, I won't have time to dive into all of that, just given the brevity of the talk, but happy to chat offline about any of those questions that folks might have. So the interesting part that we found, and initially was a little disappointing, is that marine heat wave impacts on blue whale habitat are actually surprisingly diverse. So this centroid east of San Francisco Bay is obviously not showing that we're predicting blue whales on land, but because of the shape of the coast, that is kind of the center point of blue whale habitat over the 2000 to 2020 timeframe. And then we can look at how that displaces and habitat is lost during these heat waves. So the first 2014 marine heat wave that preceded the 2015 El Nino event, we predicted over 30% habitat loss, and this basically northwest displacement of blue whales in the California current. And then we can look at the 2015 heat wave that followed, little image there just to remind folks what that looks like. We had a very similar effect where there was this northwest displacement, very strong, and also habitat loss being predicted at over 30%. Now, 2019 was a bit different. These were more offshore marine heat waves and smaller in magnitude, and we got this slightly offshore, even a little bit to the southern displacement of blue whale habitat, and habitat loss was a lot less. So this made us think, great, bigger heat wave, more habitat loss, smaller heat wave, less habitat loss. But then we looked at the 2020 heat wave, also a pretty small heat wave, but happened to be in a lot of blue whale core habitat, and we got again, slightly offshore, but even greater habitat loss predicted than in this 2019 heat wave. So the initial results, and I'll just say what we found from reviewer 2, many people in the room probably have dealt with reviewer 2. They were saying, why is this a useful tool if you're not showing any consistent trend? Well, we have seen that marine heat wave impacts are surprisingly diverse. So you can't assume, you can't say the next marine heat wave is going to have this effect. But what we can do is model marine heat waves in real time and then predict how these impacts will unfold. And so the example we kind of brought up is hurricanes are surprisingly diverse. You can't assume that future hurricanes will have the same track as past events, but hurricane tracks can be highly predictable in modeling space, so we can predict tracks in real time as hurricanes unfold. So that's what we've developed, is basically a marine heat wave warning system where we can start looking at how species are predicted to have shifts in habitat as the heat waves begin. Just another example, and this, I added these slides after some of the discussion about open data from Kristen and Kim earlier. The Whale Watch tool, which has been built over the past 10 years, we're using, again, the same historical data set of tagged blue whales from Oregon State and predicting where blue whales are in the California current using different types of remotely sensed and model oceanographic data. It started in 2017 with a monthly resolution prediction, and then at a quarter degree scale, so about 25 kilometers. But with the advent and basically proliferation of ocean models, we're able now to predict these blue whale habitat on daily time scales at a 1/10 of a degree, or 10-kilometer approximately scale. And then as part of this process, what we've done is made sure that all of our predictions are publicly available and open source, easy to digest. And so what that's allowed is for these different data sets to actually be directly ported into various tools, one being the whalesafe.com tool, which takes the model and uses it as a backdrop relative to AIS data from ships and sightings data and hydrophone data in the Southern California Bight. But then also from the Central California, these data are handed off to the ramp, which we might hear, I think, a little bit about from Ryan Bartling in the next talk, but to basically get an idea of where blue whales are most likely to be relative to risk in the California Dungeness crab fishery. So just another kind of argument or request that, again, if these data can be made public, they can be used by many other different stakeholders, sometimes in ways you may not envision, but beyond the initial intent of the tool. So I talked about the Nowcast real-time information. The initial work by Heather Welch is all available at the website here, where you can look at what top predators are responding to the marine heat waves as they develop. But then, can we do anything in the forward-looking space? And we're really lucky because here in Monterey, we are ecologists alongside oceanographers. So we've been able to get into some of the marine heat wave forecasting and try to incorporate that in our management portfolio. So another review of the marine heat wave, the blob as it was called, it formed in the Gulf of Alaska in the late 2013, expanded to reach the US West Coast in around 2014, and then was amplified, made much stronger by a strong El Nino at the end of 2015. And there've been so many, a number of papers that have talked about these ecosystem responses to this warm water event. Jared Santora and colleagues put out this concept of habitat compression. It's a very simple idea where it's tracking the 12-degree isotherm. So basically, how much cool water is there on the shelf? And you can see what happens is from 2013, 14, 15, 16, the habitat gets more and more compressed, closer and closer to shore. And luckily, temperature is one of these fields we have a lot of skill in predicting. At the same time, as the habitat compressed, we know there was an increase in potential or increase in observed entanglement rates of multiple species in the California current. So the question kind of raised is, can we use the HCI in a real-time way to say how likely are there to be an increase in entanglement risk for whales in the California current? And it's become a valuable tool there for the ramp, as mentioned, and informing these decisions and is there a need to close or not. But what we wanted to say is, if we can produce that in real time, which we do now from satellite data and ocean model data, could we actually get into forecast mode and say, what's the HCI likely to do in a month from now, up to even 12 months from now? And just jumping right to the results, this is a plot of the habitat compression index for the California current. The pink is the observed data. Lower values is more compression. So when you get close to zero, that means there's less habitat available. And then what we are showing here is the 1-month forecast of the HCI in blue. And hopefully just by looking at it, you can see there's a very high correlation that habitat compression can be forecast into the future. And if you look at that period of 2014 through 2016, I should say, 94% of the forecast correctly identified high habitat compression during the marine heat wave blob time period. The other thing important to mention, I'm not showing, but HCI forecasts correctly predicted this high compression during 24 to 2016 up to 11.5 months in advance. So this is a tool we're hoping can be useful as there's need for potential take reduction teams or other aspects regarding humpback or blue whale habitat in the California current. So last, I'll just talk a little bit about projections of long-term warming impacts. So now we're going from the daily to weekly, now on to the thinking out past potentially the end of my lifetime. And we're very fortunate that we've had some oceanographers here that have been able to downscale some of our Earth system models from the 1 degree resolution using statistical downscaling to now, again, this 10th of degree resolution. So we're at much more kind of management relevant scales. And what Mare and our group did is she downscaled 3 different models, the GFDL model, the Hadley, and the IPSL model, because they represent 3 different kind of scenarios. So the GFDL being largely cool, Hadley being largely average, and then IPSL being a little bit warmer. So that gives you, again, this kind of range of variability. So using those 3 high resolution models, we then calculated daily habitat suitability, or I should say predicted daily habitat suitability for multiple species from 1980 to 2100. And this was part of a project we called Sanctuary Futures to try to inform California, Oregon, Washington marine sanctuaries how top predator habitat was likely to change into the future that they could include in things like condition reports and long-term planning. So these changes in suitability are, again, made public. They're available for anyone who wants to use them, but they're also being summarized within these national marine refugia, or sorry, national marine sanctuary to look for things like climate refugia and bright spots, which I'll talk a little bit more about on the next slides. The other thing with the changes in the suitability, just like we did for the marine heat wave, we can look at both distance, direction, and kind of amplitude of habitat predicted changes. So again, jumping right to the results, due to the timing, we were predicting that blue whales actually had an increase in habitat suitability in the California current from historical to future. And you can see this north-northwest shift being predicted that was very similar to the 2014-15 marine heat wave. But again, the sign here, we're seeing a predicted increase in habitat while the heat wave had more of a predicted decrease. So the historical period is shown on the left. This is predicted from 85 to 2015, 30 years, and then the long-term future from 2070 to 2100. And you can see how some of the habitat, particularly in the Southern California Bight and Central California, are predicted to increase into the future. Then looking at a contrasting species for humpback whales, actually, we had a long-term prediction of actually decreased habitat suitability in the California current. So historical period on the left, in the center is that future and showing a kind of a north-northeast 114 kilometer shift in centroid habitat. And then you can look at that future minus historical period on the right to see where there's actually a lot of predicted decrease in habitat in Central California. So then what's really cool about this is by doing this for a number of species, you can look at these areas where you might have some protections in mind that are either going to be better or worse than they were in the past. So Nerea categorizes this in 4 different kind of suites of thresholds where you have historically good habitat that then is predicted to be bad, which is the habitat loss scenario. You have climate refugia, where it's good habitat and predicted to be good in the future. Unsuitable habitat to the right of that, which is bad all the time. And then bad to good and bright spots where you're getting new species. And so the way this is color coded is the more blue it is, the more species are predicted to actually have habitat gains. And those species are shown in the black silhouettes versus the white silhouettes. So you can start to get some spatial idea for where you're going to see, potential increased density or increased, I should say, number of species, diversity in the California current. And this is just another way to look at it that's sanctuary specific, where you can start looking at what parts of the sanctuaries serve as these different categories: bright spots, refugia, unsuitable habitat now and into the future, and then risk of loss. And you can start to get into these kind of fine scale cells. Again, we're not hoping that this will be useful for 10th of a degree planning, but for just, again, a long-term, as Karen mentioned, triage type approach to say which species are likely to be further impacted by climate, in addition to the multiple other stressors that they face in the California current. So into the conclusions now. This is the slide actually from the physical realm, the atmospheric prediction sphere. And you can see on the top, all the different sources of predictability, the things that allow us to have, understanding of how things are changing. And then on the bottom are the prediction ranges that we've accomplished on the atmospheric, from day to week, month, season, all the way to century. And you can see these different scales, and every one of these scales actually has different models that are used to take advantage of the sources of predictability. So weather scale, subseasonal, seasonal, annual to decadal, all the way through climate projection space. So again, there's a lot more demand, whether it's weather, and I mentioned the hurricane tracking, and for the atmospheric side, but hopefully I've convinced you that I believe we can build the same sort of multi-scale integrated portfolio to improve our ability to proactively prepare, if not respond, to climate variability and change. So just in summary, there is this increasing need, especially with things like white chip surveys decreasing in terms of funding, and these new risks popping up every day, human wildlife conflict almost every day, it feels like. So increasing need for these climate ready tools to inform management approaches. Nowcasts are very useful in providing information at the finer temporal scales, things like ecosystem status reports we use to report on this, but they can also be used to say, again, here's where habitat is most likely to be. And it's important to mention that just because we're predicting habitat, that doesn't mean that's where the species are going to actually fully occupy. If you have a whale migrating north and it finds a really good habitat in the Southern California Bight, it's not going to continue to migrate per se to the quality habitat up off the coast of Oregon or Washington, for example. But nonetheless, this can help inform targeted and responsive decisions. Forecasts can be used as an early warning indicator for management decisions. And I mean, if you think about something like closing a fishery, that can have huge economic consequences. So if we can give some warning to that so that fishermen can prepare, switch gears, look to other areas to fish, it's very similar to how we're already preparing for El Nino, La Nina conditions in agriculture and drought. And then lastly, if we have this built kind of the suite of nowcasts, forecasts, and projections, we can inform the management decisions at multiple scales and can serve as a climate ready approach as species, but also the humans that depend on them shift. And hopefully being proactive can allow us to, have our relative cake and eat it too. And then I'll just put that little point up here as I wrap up, that models can augment. But again, I'm not suggesting that we get rid of data, because we need the data not just to fit the models and refit, but also to validate as new conditions emerge. So continued data collection to make sure the models are working as expected is as important as the modeling efforts themselves. So with that, I will end on this slide just to thank to the many, many colleagues of the work I've presented. And I don't know if there's time, but I'm happy to take chat questions if there's time.
Yeah, thank you, Elliot. That was an excellent overview of all the amazing work you and your team have been doing and the potential for its use. We started the whole session a little bit early, so I do think I have time for a couple questions if there are any. Sue?
Yeah, first, thanks, Elliot. I mean, I have enjoyed your work for decades now and continue to do so. I feel very lucky that you're working in the California Current and at least stretches up to Washington State. I'm hoping for it to stretch into the Gulf of Alaska, but we'll talk about that later. My question is a simple one. Are these types of tools available in other regions? West Coast, Gulf of Mexico, that?
Yes, the short answer is, and again, some of the work that's already been presented from the Northeast, they've been really one of the leaders in a lot of the predictive modeling approaches. And there are tools available. We did have, and we still have, a little bit of funding to try to take our code and make it as publicly available and portable, so that basically it won't be as simple as you just take it and install it in a region, give it data and run, but it will allow it. It took us, these initial tools took us 2 to 3 years to build. Now we can spin up these tools in closer to 6 months with the, adequate data and such. So the short answer is that it is definitely happening in other regions. And I would say pretty much almost all regions of the US. And there's only going to be, hopefully, again, funding continuing, more opportunity for that. And yeah, we should talk more about Gulf of Alaska, because some of the new ocean models are allowing us to stretch further than we could in the past.
Yeah, any other questions? Yeah.
Hi, Elliot. I was really impressed at all the different timescales that you're discussing here. My question was, how do you convey and display the uncertainties associated with your predictions, particularly over the decadal timescales? And maybe comment on some of the sources of uncertainty present.
Yeah. Yeah, so there's a really awesome paper Steph Brody also did where she actually used simulations to, if you can simulate, here's how the animals like, we know their temperature ranges are like the chlorophyll. We use that as one of our classic ways to, model potential sources of uncertainty. And what's really cool about that, so this is just the theoretical part, but she was able to show that, in current times, most of the uncertainty is actually coming from the climate projection side, but if as you get into the future and the animals start experiencing more and more conditions outside of their historical ranges, then the error switches and the greatest source of variability ends up being more the modeling side. So if you, which makes sense because you're getting into extrapolation space, et cetera. So those kind of simulation exercises are a great way because then you have a program known, you know what these species actually like because you told these imaginary species what they like. For these models, what we do though is we always run them using withheld data. So some like 75, 25%. We tend to use leave one out approaches, which say if we have all the data, we leave out 2015, how good a job does the model do predicting on that year? And that's really important if you're thinking in forecast space, because if you just do the classic random withholding, that's not the way we get our data. We often get new data after we've already fit the model. So that's been our kind of bread and butter there. In terms of reporting it, all of these tools, we try to make sure that when we're giving a surface, we have an uncertainty surface available, publicly available as well. We've explored a lot of different ways, and I know Karen and I have talked about this in many different times that you can show like plus or minus with a confidence interval, but when you're looking at all these different grid cells, if you have a spatial map with all the uncertainty, it can be really hard to actually tease apart what that looks like. So we try to make sure it's available, but it is one of the difficulties in here, as we know it's not perfect.
Okay, thank you. I think it's time to move on. So I'm going to rely on Brady to get the next talk up. Thank you, Elliot, very much. The next speaker is Ryan Bartling. He is part of the Whale Safe Fisheries team with the California state that has been actively working to understand and mitigate whale entanglements off California in a very multi-stakeholder framework. And I'll look forward to hearing what he has to share today. Thank you, Ryan.
Thanks, Karen. And do you see my slide?
Yes, we can.
Yes.
Good.
Excellent. Well, thanks, Karen. Good morning to everyone. Just a quick introduction to myself. So I'm the senior environmental scientist for what's known as the Whale Safe Fisheries Project within the Department of Fish and Wildlife's marine region. I was asked today just to provide a kind of a brief overview of a decade or more worth of collaboration addressing California's entanglement issue. And it was great to have Elliot kind of cue a lot of this up. So thank you, Elliot. So just a quick review, and I think Jeff Moore shared a slide some of this yesterday. So West Coast entanglements history here. There's this shows all gear, all fishing gear, all species over the last about 15 years. You can see that increase in number of entanglements around that marine heat wave time period. I want to drill down a little bit, kind of how we got here. So with that marine heat wave formation around 2015, 14, that really drove a change in the fishery. Due to domoic acid, the California commercial indigenous crab fishery was delayed by several months. Unfortunately, it opened at the same time period, arriving humpback whales were returning from their winter breeding grounds. So we saw an increased number of entanglements. A couple of things of note there, based on some of the information we've been provided by some of our NOAA counterparts, there was a kind of an increased effort or redoubling of effort on improving entanglement reporting and documentation around that time. The California State Legislature had also recently, with the department, made some changes to the Dungeness crab fishery, limiting the number of traps. Trap tiers were assigned. But of note, all the traps with buoys then also had to be assigned a buoy tag. So it helped with the identification of entanglements. So I know it's been alluded to in other talks this week, but unfortunately, when entanglements occur on the West Coast, Dungeness crab happens to be one of the most commonly involved fisheries. You can see that increased number, and these are just the confirmed entanglements. This does not include those that are unidentified, where the fishing gear cannot be definitively decided upon. So that really kicked off the formation of what's known as the California Commercial Dungeness Crab Fishing Gear Working Group. This was a collaboration with NOAA Fisheries and NIMS, along with the Ocean Protection Council. It formed what's really colloquially known as the working group. It's comprised of commercial and recreational fishermen, environmental organization, members of the Disentanglement Network, and numerous state and federal agencies. It was established in 2015, late 2015. The goal really was to support thriving whale populations and a thriving, or at least provide fishing opportunities for the Dungeness crab fleet. Initial work was really focused on what was known as the risk assessment mitigation ramp pilot, discussing gear modifications, what are some things the fleet could do to minimize the risk of entanglement. Ongoing work, and I'll talk more about that, continues with the risk assessments and lost gear recovery. We've made a lot of strides and progress in removing derelict gear out of the ocean. So as I mentioned, the initial work of the working group focused on the ramp pilot. There were kind of 4 area factors, looking at entanglement history, species abundance and distribution, forage and oceanography, and then of course fishing dynamics. The working group would meet and discuss available data and make really what was a qualitative assessment of risk based on ocean forage, recent entanglements, and what kind of fleet activity was currently occurring. That would all change in 2020, but I'll talk more about that in a second. Other the collaborative projects they worked on kind of initially was developing a best practices guide. That continues today. The department updates that on a regular interval. It's basically a public outreach tool to the fleet, including the recreational fleet, of best fishing practices, minimizing scope of line, reminding them of the surface gear restrictions. They also attended and participated in disentanglement trainings. They helped with the reporting, and that continues to today. They also participate in initial whale and crab gear distribution surveys. And then one thing that's been really important and we're building on, I'll talk about, is an electronic monitoring pilot. I think it was almost 40 vessels participated in this pilot, where each was outfitted with electronic monitoring device built by Pelagic. It was a solar logger, and it was giving real-time information on a vessel location. So fast forwarding to 2020, that ramp pilot, the department was given authority in 2018 to develop the program. It was a lengthy public process and involved the working group, of course, and ramp regulations were adopted in November of 2020. What ramp really is, it's an adaptive management assessment of entanglement risk. We'll call them almost near real-time assessments. Our team runs monthly or sometimes bi-weekly assessments, and those begin in October, which is next month already. And it's before the season opener, which can open as early as November. It's a huge undertaking. It involves numerous scientific partners, Karen being one of them, Elliot, Jared Santora, John Kalmakidis, Scott Benson, just to name a few. Involves fishermen and multiple functions within our own department, law enforcement, of course, our scientific staff, general counsel. While the season remains in statute, this program gives our director the authority to delay the season when the assessment is shown that risk is high of entanglement. It uses the best available science with a variety of inputs, and there's a variety of tools that director can use beyond even just the season delays and closures. Those data inputs, just to highlight a few, habitat compression index, Elliot mentioned aerial and vessel surveys are particularly important. Entanglement tracking and information is essential. Understanding available or the fishing season dynamics. Sea turtle surveys have been invaluable in informing the director on potential delays or closures. And then vessel monitoring, which is something I'll talk more about in a moment. So this is kind of what it looks like in the real world for us. Our staff put together what's called an available data document along with a recommendation. This is informed by our data contributors, which covers numerous folks from aerial surveys, habitat compression information, if the season's open, fishing dynamics, oceanography or oceanographic information, those species distribution models, all gets fed into this. Staff make a recommendation. We meet with the Dungeness Crab Fishing Gear Working Group, uh, and then we share that information out with the public, and ultimately the director makes a decision informed by that information and a recommendation from the working group. Highlight those marine life concentration surveys have been particularly important. That's really what has driven the season delays at this in November and December. For those of you in the Bay Area, I'm sorry for the delay in getting your crab for Christmas or Thanksgiving, but these surveys have been essential in informing when we can open the fishery with less entanglement risk. So when the director goes to make a decision, he has a variety or options for tools here, from as minimal as a fleet advisory to as restrictive as a season closure. Informed by those data, the director's implemented depth constraints where we bring all the fleet inside the 30 fathom contour, trying to keep them from overlapping with whales that are feeding particularly closer to the continental shelf. We've implemented vertical line reductions. So, as an example, some vessels can fish up to 500 pots. Under a vertical line reduction, the directors implemented a 50% reduction. So, their gear is essentially cut in half, removing all those vertical lines, or not all of them, but at least half of them per vessel. And that's reducing that likelihood of co-occurrence by getting many of those lines out of the water. And then I mentioned fishery closures and delays. And then we've been working on alternative gear development, and I'll talk about that in a moment with our experimental fishing permit program. But alternative gear can be used after a season closure once that's been implemented. So some ongoing work. I mentioned the solar logger that has spun off into the department this year. Will be implementing 100% electronic monitoring for the commercial Dungeness fleet. We're using an archipelago unit. Almost 400 vessels will be transmitting location data on a 1 minute ping interval. The goal with this information, at least for the future, is to have a better understanding of where the fleet's fishing, where those high activity areas are, and then either looking at species distribution models or real-time aerial survey data or other to really refine our management decision making and potentially close smaller areas, but that would be a future thing. And then again, just really highlighting those aerial surveys. We've had a number of partners. The commercial Dungeness crab fleet has been particularly interested in supporting their own vessel surveys. Karen and others, John, had helped them develop a survey methodology. They've been looking for some funding opportunities to continue to build on that. And that's really had provided kind of some localized fishing zone area information that we've been able to utilize. Another collaborative approach we've been working on is in dealing with this unidentified entanglement category. So on the West Coast, Oregon, Washington, and California have come to an agreement to develop line marking approaches for all of our state managed fixed gear fisheries. So this first rollout, we're working with Dungeness crab because, as I mentioned, it's the most most likely involved in an entanglement fishery. California we're about midway through the distribution. We're outfitting the entire fleet with purple and black rope. This will mark all the vertical lines, that upper top shot, and then the surface gear. This will aid in entanglement identification. Oregon is using yellow and black, and then Washington is using red and black. And the common theme here is black designates the fishery, Dungeness crab, and then the color is unique to the state. So the state color is California. And we've already seen this help aid in identification. We had an entanglement off Eureka earlier this summer, and we were able to see that purple and black. So we're already making progress there. And then we'll be rolling this out to our other state managed fisheries as time allows. Experimental fishing gear, and this is kind of gets back to the alternative gear. So for the past 3 or 4 years, the Fish and Game Commission and the department have been issuing experimental fishing permits in California. And essentially what that does is allows commercial and recreational fishing activities that would to occur that would otherwise be prohibited. Made a lot of progress here just this past season. Just for the Dungeness crab fishery, we had over 20 vessels participate. Almost $2 million were landed in a very short period using ropeless systems. Shows a lot of promise. The goal here is to use this type of gear during a closure, provides fishing opportunities while removing that risk of vertical lines. Since the start of the EFP program, there's been 5 EFPs issued, 3 specific to the commercial Dungeness crab fishery. The fleet themselves actually sponsored a EFP where they're using no vertical lines, using a common ground line with all traps connected to that common ground line, and they grapple. And that, from what we've been told, that's been fairly successful. And then the last collaborative approach I'll mention is the department's been working with the National Marine Sanctuary Foundation using Ocean Protection Council money. They funded a gear library, and it really provides access to particularly ropeless gear and its technology at low or no cost to the fishery. And we've seen an expanded interest in using it in our other state managed fisheries. Coonstripe Trip fishery has shown interest, and I know today, in fact, Greg Wells, who's managing that library and the program for them, is out with a spot prawn fisherman doing some initial testing and bringing them up to interest for ropeless gear. So with that, I will just say thank you for the time. I appreciate the invitation. This has been a really interesting thing. I've learned a lot and I'm happy to have had the opportunity to participate. I feel like we've done a lot in the last 10 years. We've got a long way to go, but it's not without this collaboration, we would not be where we are today. I'd like to think California is kind of leading the way in this real-time fisheries management, trying to address entanglement risk. And it couldn't have been done without the dozens and probably hundreds of partners over the last decade. So with that, thank you.
Thank you, Ryan. A really nice overview of this important program. And I do think we have time for a question or two, again, since we started the whole session early. Are there any questions? Erin?
Hi, Ryan. Thanks. Great talk. Any thoughts about what you mentioned, implementing full colored rope to a fishery as opposed to marking like some of the things we're doing in the Northeast where we have zip ties that are regularly spaced? I know one concern that we have is it would be great to ID the gear from aerial survey. And right now, it's very difficult with the way we mark our gear.
Yeah, thanks, Aaron. We actually had looked at some of the work you guys had done on the East Coast with the zip ties and I think tape and other things. And I guess we went with I'll call it a more aggressive approach, having actual manufactured line. It comes with a cost, obviously, and that's been one of the bigger barriers. Whether we can identify from the air, I think that'll be to be determined. But I think this initial rollout, this coming season, all surface gear will have to be marked. And then beginning next year, we do a phased implementation over 3 years where the upper 15 fathoms will be marked. And based on the entanglement reporting information that's been made available to us, we have some higher level of confidence that them will have marked enough and with enough differentiation from the other types of gear that's out there in other states that it will be marked. So I don't know if that answers your question. We're hopeful that we're taking the right approach, and we've tried to deal with the cost issue for the fleet, because that's one of the big barriers is rolling this out. So
Thank you. Any other questions? I'll take one more if there is one. Yes, go ahead in the back.
Can you hear me? I'm Jim Bishop. I was formerly a commercial fisherman a long time ago in California. Is it a limited entry for Dungeness crab permits? Or is it open to anybody that decides they want to do that under a global permit?
yeah, good question. No, it is a limited entry fishery. It's been that way for probably a couple decades. Don't quote me on the exact year. In California, there are about 530 limited entry permits. We have seen some attrition, but generally from season to season, we see about 360 to 380 vessels actually participate. So what that means for vertical lines, because I think it's important to note, which I didn't mention, when all those vessels are active and fishing their full tiers, you could have 120,000 vertical lines out there. So that's why the whole ramp program is really designed to reduce that co-occurrence by removing these vertical lines.
Okay, thank you. Then I think we'll move on to our next speaker, Amy Lang, on the monitoring and status of the Eastern North Pacific gray whales. Hi, Amy. Good to see you. And I'll hope that with Brady's help, you can get your presentation going.
Just to be clear, all these speakers have done their presentations themselves, so I don't get any credit.
Then I take it all back.
All right. So can you guys see my screen?
Yes, looks great.
Okay, great. So thanks, Karen. So I'm Amy Lang, and I'm here today to talk about the work that Southwest Fisheries Science Center has been doing to monitor the status of Eastern North Pacific gray whales. This is work that's led not only by myself, but also by Tomo Oguchi, Trevor Joyce, and Dave Weller from the Marine Mammal and Turtle Division. And it's actually the product, the surveys that I'm going to talk about are the product of really division-wide efforts in that the surveys that we conduct require participation of staff from across all the programs in our division. And Karen is quite familiar with these. She's been an observer on these surveys several times in the past. So most Eastern North Pacific gray whales migrate between feeding grounds in the Bering, Chukchi, and Beaufort Seas, and wintering grounds in the lagoons and coastal waters of Mexico. And for much of this migration, they remain quite close to shore, and that has greatly facilitated our efforts to monitor the status of this population. So we can gather a lot of information on Eastern gray whales without needing to be out on the water or be out on an expensive ship-based survey. So today I'm going to talk about what we've learned from conducting shore-based counts of gray whales from 2 sites along the coast of California. And then I'm also going to talk briefly about some of the work that we've been doing using uncrewed aerial systems to improve our ability to monitor the population. So the objectives of the 2 surveys that we do are different. And the first one I'm going to focus on is focused on estimating abundance in the Eastern North Pacific population. This survey is conducted from Granite Canyon, California, which is just south of Carmel by the Sea in Central California. And for this survey, we're counting whales as they migrate south between late December and mid-February. And we use these counts to generate an abundance estimate for the population. This time series dates back almost 60 years, which is pretty incredible. And to my knowledge, it's produced the longest time series of abundance that's available for a baleen whale population. Initially, these surveys were led by the Alaska Fisheries Science Center, and Southwest Fisheries took responsibility for them in the winter of 2006, 2007. And when we first started, our strategy was to conduct the counts in 2 consecutive years out of every 5. But for reasons that I think will be clear in a minute, we've increased that frequency recently. So the methodology we use for these surveys is probably best categorized as traditional rather than emerging, with the exception of some of the UAS work, I would say. This site was chosen because it is just south of a deep underwater canyon in Monterey Bay, and that means that the whales migrate particularly close to shore here. And so most of the whales migrating south past this area can be seen by observers simply by naked eye and using handheld binoculars. So for this survey, we work in teams of 2, basically just scanning our study area and logging any sightings using some specially designed software that helps us to keep track of groups as they're migrating through the area. So the eastern North Pacific population of gray whales received full protection from commercial whaling in the mid-1940s, and these counts started about 2 decades after that time. So presumably the population had begun to recover by that point, but it was still at relatively low levels and was estimated to be about 13,500 whales when these monitoring efforts began. Monitoring over the next couple of decades showed a general pattern of population increase, and the DPS was delisted from the endangered species list in 1994. And at that point, the abundance was roughly 20,000 whales. Now, one of the requirements of delisting was that we continue to monitor the status of the population. And so for the next few years, we saw that the population's abundance remained relatively stable. However, in 1999, we started to see a sharp increase in the number of stranded whales along the coast of North America, and that marked the start of the first recognized unusual mortality event for the population. Coincident with this event, we also saw a decline in the population's abundance, which dropped from about 21,000 in the late 1990s to about 16,000 in the winter of 2001-2002. Now, there was a gap in our survey effort between that point and the winter of 2006 and 2007. But by that point, the estimated abundance had risen to almost 21,000 whales. And it continued to rise for the next several years, reaching a high point of between about 25 and 30,000 whales in 2015-16. However, the number of stranded whales again increased markedly in 2019, and that marked the start of the second recognized UME, which extended until 2023. And you can see here, during that UME, there were a total of almost 700 strandings recorded on the coast of the western coast of North America. So not surprisingly, we also saw that the estimated abundance declined during that most recent UME. It dropped to around 13,500 to a little over 16,000 whales by the winter of 2022-23. And this represented an approximately 46% decline from the high that we'd seen in 2016. Although we saw an apparent increase in the abundance estimate based on our survey in the winter of 2024, this past winter's efforts resulted in an estimate of about 11,700 to 14,500 whales. And that's in line with the numbers that were estimated at the start of the time series in the late 1960s. Thus, not only was this UME longer in duration and the decline of greater magnitude, but we are also not seeing any convincing signs of recovery thus far. So switching gears for a minute, to talk about our other survey. This survey is conducted from the Piedras Blancas Light Station near San Simeon, California, also in Central California. This survey is focused on monitoring calf production in the population. And so the focus here is on counting mom-calf pairs as they migrate north past this site. And this site was chosen because it sticks out kind of on a point of land that allows us to look south and get a pretty good vantage point of seeing the mother calf pairs as they migrate north. They typically stay really quite close to shore through this area. So we do these counts between late March and the end of May. And we've been conducting the counts annually since 1994. So we have about over 30 years of survey data on calf production based on this time series. And similar to the other survey, we use pretty simple methodology here. We work in teams of 2 observers scanning the area with handheld binoculars and by naked eye. And then just record the mother calf pairs and sighting conditions while we're on watch. So you can see the results, the time series that's been generated from those surveys here. And I think the first thing to notice is that there's a lot of variability in the calf production over time. So there are years when we estimate more than 1,500 calves are produced in the population, and other years when the calf production estimates drop below 500. And you can see here that there was a period of low calf production that coincided with the 1999 to 2000 UME. And that persisted into 2001 and then increased to more moderate levels by 2002 and then up to high levels just a couple of years later. We saw another period of relatively low calf production between 2007 and 2010, and I'll come back to that in a couple of slides. And then the most recent period of low calf production started in 2019 with the more recent unusual mortality event. So calf production, after that event closed, calf production has remained low in 2024, and then it hit the lowest level of our time series by a pretty marked amount this past season when we counted only 17 calves, mom calf pairs, over 8 weeks of survey effort, and that estimate of calf production was around 85 calves. And I would say that this is perhaps of greater concern even than the decline in abundance, in that it sort of allows us to look into the future and suggest that we're not going to be seeing there's not going to be a lot of new reproductive females recruiting into this population in the future after this 7 years of low calf production. So just briefly, I wanted to note that while the types of data that are collected are not necessarily equivalent, we've not seen the same patterns in gray whales that feed in other areas. So for example, when we look at the abundance of the Pacific Coast feeding group of gray whales, which are the gray whales that feed between Northern California and Northern British Columbia, we have seen a slight decline since about 2016, but nothing of the magnitude that we've seen in the Eastern North Pacific. And then although we don't have recent abundance estimates from the Western North Pacific gray whale stock, we do have counts of calves observed each year, and they're shown on that graph in the bottom left with the blue bars. The Eastern North Pacific calf production estimates are in the red bars, but they are, of course, scaled. So they're about 100 times greater than the Western North Pacific. But the main point here is that in recent years, the number of calves seen in the Western North Pacific has actually been relatively high compared to earlier years of that time series. So that really contrasts with what we're seeing in the Eastern North Pacific. So what is driving the variation in abundance and calf production in the Eastern North Pacific gray whale stock? So over time, we've been able to put together some pieces of this puzzle, but more recently, we were able to answer this question more comprehensively, thanks to work that Josh Stewart, who's now at OSU, but started his work as a postdoc with Southwest Fisheries, the work he put together to produce an integrated population model for gray whales. These results were published in 2023, and they've shaped our current understanding of what's driving the fluctuations in abundance and calf production in our time series. The integrated population model uses as input both our abundance and calf production time series, as well as time series on strandings or mortality and body condition. The IPM also incorporates measures of variation in sea ice cover, which limits access of whales to prime feeding areas early in the feeding season, and measures of benthic prey biomass. And the IPM revealed that population declines are associated with high sea ice cover and low benthic prey availability. This was true not only of the two recognized unusual mortality events in 2000 and 2001, and the more recent one that started in 2019, but it was also true for the decline in abundance that was seen between the mid-1980s and early 1990s. The two periods of low calf production that occurred during the UMEs were also associated with high sea ice cover and low benthic prey availability. The period of low calf production in 2006 to 2010 was associated with low prey availability but average ice access. So essentially the low prey in that year was kind of offset by the whales being able to access the prime feeding areas early in the feeding season. So the integrated population model has provided some really valuable insight into what's behind these boom-bust cycles we've been seeing in gray whales, where the population increases but appears to reach a carrying capacity, and then experiences these sharp declines, after which, at least for the two prior declines, the population began to increase again. And these results really point to the value of long-term data series and the integration of multiple data types to elucidate patterns in the population dynamics of these whales. And then the final thing I wanted to touch on briefly today is one component of how we plan to use the uncrewed aerial systems observations to improve our abundance estimation. And this is work that's led by Trevor Joyce, who's the UAS expert on our Southwest Gray Whale team. And I should note here that a key assumption of our modeling approach, which I didn't really go into detail about, is that we currently use for the abundance estimation model is that the estimation of pod or group size is effectively unbiased. However, that is an assumption that has never been explicitly evaluated in the context of our particular model. So to address this and other questions, Trevor was able to obtain authorization to fly small UAS beyond visual line of sight out to distances up to about 5 kilometers or 3 nautical miles from our ground station location. And that allowed he and his teams to complete 148 long-range focal tracking missions from the Granite Canyon Station during the 2024 and 2025 visual observer seasons. These missions targeted specific gray whale groups migrating through the visual survey study area between 1 and 4 kilometers from shore, with the primary goal of collecting information on group size. Now, one challenge of using this approach is linking the sightings made by the visual observer teams with those recorded on the UAS missions. Well, I actually had a video here, but it doesn't look like it's going to play. But let's see. So essentially, Trevor has identified a way to overlay the sighting data that's recorded by our visual observers with the UAS tracks, and to use the criteria based on the number of groups in the area and their proximity to the UAS track to link the groups observed by both the two platforms. And thus far, using this system, we've identified 51 UAS observed groups that can be linked to visually observed groups with sufficient confidence to allow for comparison for the purpose of group size calibration. And this work is still in progress, but the preliminary results indicate that in the majority of linked sightings, the UAS group size estimates exceeded the estimates made by visual observers. And that's perhaps not particularly surprising given the difference in methodologies and the ability for the UAS observations to see whales when they're below the surface of the water. And then finally, looking into the future more broadly, we're always considering ways to improve our ability to monitor abundance and calf production in the eastern gray whale population, while also keeping in mind that we need to keep the time series, the integrity of the time series intact. And to that end, Tomo Oguchi, who's the lead in our Cetacean Health and Life History program, is currently working on a revised abundance model that will improve our approach generally and will allow integration of estimated correction factors for group size into the future. So that's in progress. Literally as we speak, I think we just got a recent draft of a paper from Tomo just this past week on this. And so with that, I just wanted to conclude by saying that while there is, of course, uncertainty in our funding situation moving forward, we are currently in the process of planning the 2025-26 Abundance Survey in Granite Canyon. So we're hoping we're going to have more information on the status of the population in the near future. And I'm happy to take any questions, and I just want to thank you for inviting me to give the presentation here and to talk a little bit about gray whales. Thank you.
Thank you, Amy. We do have time for some questions, so I'll see the commissioners. And yeah, Sue, I had a feeling you might have some questions.
I do have questions, Karen. First, Amy, thank you. That was an excellent presentation. And my question really is about the estimate in 2023-24, the about 17,000. I wonder if you could say a few words about that. I understand that there were some issues and it seems to be ignored. And so I'm just wondering if you'd elaborate on that a little bit.
Sure. And I don't know if I'm going to have a super satisfying answer for you there, but essentially, you know, throughout the time series, we've seen these these significant increases in abundance that happen from one season to the next that we can't explain by demographic factors. So they're basically not biologically plausible, right? It's happened several times in our time series. And it's happened even not only for our current abundance estimation approach, but also when we were using the original Jeff Lake et al. Abundance approach, we also saw those big jumps. We do have efforts underway to determine the reasons for those sudden increases. We think they're probably caused by biases associated with the mismatches between some of the analytical assumptions, maybe in the sampling as well as in the modeling and the migratory behavior of whales in those particular years. But we don't at this point have a satisfying answer for why we had that apparent increase in the 2023-24 winter and then saw the much lower estimate this past winter. I mean, I guess I would say that the low estimate this past winter is more consistent with the other data sources we have about what's happening in the population. It's consistent with this, the low calf production. It's consistent with the fact that stranding rates are now back up again this year. Unfortunately, I think that the more recent estimate is the more reliable one, but we don't have a good explanation for what factors were driving that jump in the abundance in the estimate that previous year.
Yeah, thank you.
Yeah, Andy, I see you have your hand up.
Yeah, thanks, Karen. Amy, thanks again. This is really good, really great work. I think we talked about this before, but and Sue might have just touched on it, but the concept that maybe not all the animals are going to make the southward migration, right? And there might be animals somewhere else, which could help in the year-to-year jumps. Just thoughts about that and what might be done to kind of assess that possibility.
Yeah, so we have had a fair bit of discussion about the possibility that it seems entirely plausible that not all whales are going to be migrating south, particularly when you're thinking about, whales are in poor body condition. What's really the motivation for making that really long migration? So I think that could be at play to some extent and account for some of the variability in our estimates. That said, it seems really unlikely to me, at least, that there would be whales that are staying north and not migrating that number in the several thousands, which is what we would need to explain these patterns that nobody's detecting. So I don't think that that's a full explanation. I do think it's could be at play here. And there were some observations this past winter of gray whales that appeared to be staying north and not migrating. And so we know that does seem like it's happening, but I don't think it's a full explanation for these patterns we're seeing. And in terms of just monitoring or getting a better understanding of that, I think there might be some work we could do with acoustics monitoring, but that assumes that the whales are making sounds while they're up north. And so I'm not sure how we would exactly get around that. Otherwise, there's just not a lot of a chance for whales that if they're staying up in the Arctic year round for them to be observed in the winter. So it is a bit of a question mark.
Any other questions? Oh. I'll take Aaron and then Peter.
Just one other thought, and building on something Elliot said about the blue whales, is it possible that there's an onshore-offshore component to the migration? Your viewers are on land, right? So there could be an availability bias from year to year.
There is a possibility that that's at play, and that is on our radar. There were some aerial surveys and some experiments done with big eyes to kind of assess the offshore distribution and how, were we able to capture most whales from shore, and was there big changes in the offshore distribution from year to year? Those were done in the past, but I mean, like in the 1980s, early 1990s. So those, if something has shifted since that time, it is possible that we're missing some whales that are migrating further offshore. And so we have talked about how to address that potentially with some UAS transects. We've talked about potentially using eDNA to do some transects offshore and see if we're picking up any spikes there. But so far we haven't had the resources to really take a look at that, but it is something that's on our radar.
Okay, thanks. Peter, go ahead. And I see Randy also has his hand up after that.
Sure, thanks, Amy. Just two basic questions. One is, I assume the calf count is corroborated by what's being seen down in the calving lagoons. What's the story from down there this year? And the other element, I know there's been a lot of work on trying to evaluate the unusual mortality events. And is there sort of basic work on body condition of the whales at this point through the UASs or other means? Thanks.
Sure. So with respect to what they've been seeing down in the lagoons, yes, I think our observations are very consistent with the number of calves they've been counting in the lagoons these past several seasons. And in fact, I think they also had their lowest number of mom calf pairs seen in the lagoons. I can't remember the exact numbers, but it was really quite low. And then with respect to body condition, yes. So the images that Trevor's collecting that we're using currently to look at group size estimates, a lot of that data can also be used to look at body condition of the southbound migrating whales. He hasn't started doing that. He's been focusing mostly on the group size calibration currently, but we do have plans to use that data to kind of to take another look at body condition, which we had done in the past. A lot of the work was done from Piedras Blancas with the northbound migrating whales, but we think looking at the southbound migrating whales might be a better indicator since they're just coming right off the feeding season. So I think Trevor will be using that data to look at body condition. And then we also have, I think, a couple of seasons of small boat work where off the Channel Islands where they were able to launch a drone and collect some body condition data, but we just haven't fully gotten that summarized in the workshop.
Thanks, Amy. And Randy, you have some questions?
Yeah, thanks, Amy. As usual, really interesting stuff, and I'm sure there's a lot of additional interesting stuff is in the offing. Could you say a few things about how you interpret the differences between the so-called Eastern migratory population and the PCFG, and in terms of trend and numbers recently, and the Western group?
I mean, I think the fact that we're not seeing the same patterns in the PCFG and the Western North Pacific gray whales in terms of the high mortality or the declines in abundance is really sort of corroborates that this is what's happening to the greater Eastern North Pacific population is limited prey resources up in the Arctic, that's really driving this decline. And those, that's not true of the feeding grounds, presumably used by the Pacific Coast Feeding Group and the Western North Pacific whales. So I think the reason we're seeing that discrepancy is kind of support for the fact it's an Arctic, it's what's happening up on the Arctic feeding grounds with declines in the benthic prey. Does that address your question generally?
Yeah, that's fine. That's helpful. I also can't help but wonder the situation with regard to mammal-eating killer whales and their inclination to eat baby gray whales, but of course that doesn't happen before they pass north along the California coast, presumably, much at all. So it shouldn't affect that.
It should be hitting all three groups of the animals that migrate down to Mexico, at least, I would think, would have the opportunity to be taken by the killer whales. It is, to me, it's a very interesting question because the killer whale predation, it's best monitored, I think, off Monterey Bay. It can be so extreme in some years, and kind of what happens in these years where there's almost no calves to be had is kind of an interesting question to me. And one other, I think, just sort of interesting point to make with the calf production in the different groups is that in Mexico, I believe, I might have these numbers slightly off, but I think they had in one of the lagoons 7 mother calf pairs this year, and 2 of them were animals that had been seen off Sakhalin, which is a pretty interesting to think that 2 of 7 that they saw in that lagoon for that whole season were Sakhalin animals that at least at one point have been moms that had been seen off Sakhalin. So it's made me wonder how much of the calf production we saw this year could be attributed to PCFG or Western North Pacific gray whales.
Thank you.
Yeah, okay. And a little birdie told me that Mike had one more question. We're due for a break, but I'll take that one and then we can move on.
That's a related question, which is what are you seeing in the trends of the Western North Pacific gray whales that are being detected off the West Coast?
I'm not sure we have great information to address what kind of trends we're seeing, but there are still, our colleagues down in Mexico do regularly make comparisons of the animals they're seeing in the lagoons with the Western North Pacific catalog, and they do continue to make matches. Some of them are animals that have been seen, Sakhalin animals have been seen previously in Mexico, which I think is pretty interesting. We're getting some repeat observations of some of those individuals in Mexico. But I can't really comment on really a trend other than that they do continue to identify Sakhalin animals down in Mexico.
Okay, thank you. Thanks for all those wonderful questions. Even though we started this whole session ahead of schedule, we are now officially a few minutes late to our break. So I call that success. So anyway, the agenda says we have a coffee break now until 11 o'clock, and then afterwards Clarissa Anderson will talk to us about harmful algal blooms. So enjoy your break, and anything else? Okay. All right, I think we're ready to, are we recording yet, or?
Yes, we're recording.
Okay, thank you. Well, welcome back, everyone. Hope you had a nice break. And we're going to move on to the last talk of our session. Last but not least, for sure, my pleasure to introduce Clarissa Anderson to talk about harmful algal blooms here on the West Coast.
Thanks, Karen. No problem.
I should have set up your talk already.
That's okay. Yeah, we're gonna shift to the base of the food web now.
No. Sure.
Save, don't save. Delete everything. I know, I'm not touching anything.
We've seen what happens. And let's just make sure. Yes, this works great. Either
All
buttons
right.
or mouses or arrows.
Yeah, we'll see. Okay, not to push too many buttons. Hi, everybody. It's really a pleasure to be here. And I will be switching to the base of the food web now, so it will be a little different. And I've been learning so much the last couple of days. It's been a real pleasure. And I know a lot of you don't know me. I don't know all of you because we are in slightly different communities. But just as a background so you know where I'm coming from, I'm a biological oceanographer. My training really is more on the side, and my research more on the side of remote sensing and modeling of plankton and toxins in the ocean. I won't be really going into as much of that today as I might like. But what we're going to do is talk about marine mammals, which is not, obviously my specialty, but I have countless partners and collaborators not listed here. Many are in the room. I mean, Alyssa was in the room. Where did she go? Alyssa Deming from PMMC, Francis Goland. So many people who I think are just pioneers and heroes in this realm of work we do with HABs. There's Alyssa. I just gave you a shout out before you came in the room. Woo, woo. And so it's painful that I can't put all the names here and haven't put all the names here because there are so many great people. You're going to see a lot of their work and the data that comes out in this talk. And so here at Scripps, I am the director of one of the regional associations of IUCE, which is SCOOS, the Southern California Coastal Ocean Observing System, and then also the director of CMIS, which is one of the 16 cooperative institutes for NOAA in the country. And ours is the Marine Earth and Atmospheric Systems, in case you were trying to backronym that one. So yeah, it is September 11th. Interesting day to be giving a talk. There's so much happening in the world, but we're going to focus our attention on the animals that are often underlooked in all of the discussions that we have. And I want to start by also acknowledging my incredible team at SCOOS, two of whom are now in the room. We've got Danielle up in the rafters, and Natalie is there. So we have a great team that's going to it is integral to a lot of the information I'm going to share today in terms of compiling data, sharing data, working with all of our partners and our stakeholders to make a lot of what we do happen in the harmful algal bloom realm. So in way of background, to get you acquainted with what SCOOS does and why we're even playing a role in any of this, it goes back to about 2008 when many of the folks doing harmful algal bloom research in California got together in a room at SCORP and said, we need to codify how we do this. We need to have more of a sustained long-term monitoring program for harmful algal blooms. So if you think back to 2008, just the year before, we'd had a pretty big marine mammal stranding event. You go back 7 years, even further, to some of the biggest and most, the earliest ones. We really connected the dots between California sea lions and domoic acid. So it was starting to look pretty critical that we get these sorts of alerts down. And at that time, it was really just weekly sampling, and it still is. So that's the California Harmful Algal Bloom Monitoring Program that then SCOOS and SENCOOS are the SCOOS of the North. We came together and we decided how to sustain this through funding from IUCE, which comes as annual allotments to run these major programs. And they are major programs, a little dwarfed by the Cal Coffee lines on that map, but what you might not appreciate is just how much we do at SCOOS. This kind of physics to mammals approach where we're trying to look at the ocean from a holistic perspective, end-to-end ocean observing, everything from all the different kinds of physical measurements, biogeochemical measurements, biological, and so forth, and then try to integrate that and tie it together. So no easy feat. And I'll talk a little bit more about HabMap in a minute, but in recent years, we've been able to flesh out that program, grow it to be more of a real-time program where we're moving from the weekly assessment to real-time plankton assessment by putting in what is now the largest network of imaging flow cytobots in the world. So we've got 12 in our network, 9 are operating operationally, and let me be clear, that is a stretch to even use that word operations for something this over-engineered and complicated, because it is like whack-a-mole. We've got 6 probably working really well at one time, and then all of a sudden they all crash, and then 3 more pop up. And it really is challenging, but I'm not here to really go into a lot of detail about that network, but just to say that these are beautiful tools that give us gorgeous imagery. We're getting them 20 minutes to hourly basis. We're applying machine learning algorithms to those images, and that gives us this ability to give daily, sub-daily information to all the different partners who need to know which taxa are growing, which ones are terminating. It does not give you toxins, but it's still a really critical tool, and we're learning a lot more about it. So it's not been that many years that I can call this an operational network, and it really does take a huge number of people to make that happen, and they're not all listed here. But going back to sort of what was the bread and butter for so many years for the HAB monitoring in California is this HabMap program. And it focuses on several key taxa. It focuses on primarily domoic acid in terms of toxins. There are sites where we get more toxin measurements, particularly like Rafe Kudela will run a whole suite. But for the most part, we have focused this effort on doing something that not a lot of places do, which is having the physical and chemical records alongside all of these biological records so that we can go back and piece together predictive capacity. It has been a really great tool for working with the California Department of Public Health. And then over time, we've really tried to establish a connection with the marine mammal rescue groups so that we can make these data more important, efficient, useful, et cetera. Also, let's just go back for a minute and talk about the food web, because I'm putting a lot of emphasis now on plankton and their role in what's going on with the marine mammal populations and strandings right now in California and over time. But in the early days, it might not have been obvious what was happening, but with Francis and people like Kathy LaFay just doing a lot of the critical early work and to make that connection of how do we get from domoic acid in the cells up to these higher trophic level top predators. And it does require the fish, it requires the forage fish. We kind of laugh sometimes in our space because I get asked a lot, and I'm sure some of you do too, when there's a harmful algal bloom about what it means for a human to swim in that mixture or drink that water. And I think, well, if you're not planning on eating thousands of anchovy a day, you're probably going to be okay, at least in the short term. We won't talk about chronic exposure so much right now. But the food web thing is really critical, and I'm going to get back to this towards the end of the talk. But not only was it established that you needed that sort of that connective tissue in the food web, but the years where we have a bloom or at least some background domoic acid and not a lot of strandings versus years where we have like the 2015 event where we just had this epic event with the worm anomaly, lots of strandings. The food webs are different and they can be longer, and some of these things we're kind of teasing out with some stable isotope work in recent years can maybe help us understand the variability in strandings, which is kind of a critical question, because if you ask me what are the harmful algal bloom years, I might give you a very different answer from the marine mammal stranding folks who are going to have their subset of those events that are the marine mammal stranding years, because I'm always just looking at it from how much DA was in the water. Does that mean we had strandings? Not necessarily at all. And so one of the ways we're thinking about this from a synoptic perspective on the oceanographic side is through modeling of the organism, trying to get beyond our limitations on the monitoring side, which really are confined to the coast, and think about what it means for these animals that are foraging over large distances and in the subsurface. And so the California Harmful Algae Risk Mapping System, CHARM, which was something I worked on with a large team for years to develop, is, I think, still in the US, the only phycotoxin forecast that you can get like this, like a spatially explicit forecast, not just of chlorophyll or a particular plankton, but of the phycotoxin itself. And we birthed it into operations at NOAA years ago now, in 2018. So Coast Watch is the home for that, and the West Coast node particularly kind of comes through the Cooperative Institute, actually. And this is a 3-day forecast of the probability of encountering high domoic acid in the environment. We also have it for Pseudonychia. And I'm showing you the map, which is really a mean map of that probability over the last 4 years, because we've had this incredible spate of marine mammal stranding events over these last 4 years connected to high domoic acid. And what you're seeing here is maybe not a perfect matchup between the magnitude, the darkest orange colors, and the number of animals that ultimately stranded. It's not going to be a perfect one-to-one match. And again, that gets back to what happens in the food web. And we don't have those data. But it is a very helpful spatial metric. It helps us look at these blooms as they unfold in real time from a synoptic perspective. It does match up pretty well with the places where we see more strandings than not. For instance, in 2025, the bullseye of strandings were kind of Santa Barbara, LA, Orange County, and you can see that, where the darkest orange colors are kind of more skewed to that Southern California distribution. These blooms in the last 4 years have really been confined, I would say, central to Southern California, at least in terms of the strandings, not always where we see domoic acid. And so we're here partly today to talk about why is this happening. 4 years in a row is unusual by any metric. And there's still a lot of questions. I will not be answering them all today, but I just want to make the point here that we do have one tool that is useful, and it does track strandings pretty well. And you'll see, though, that like in 2025, we had the most animals, and we're trying very hard to plot these data. This is an imperfect, absolutely hugely imperfect time series to show you, because we're just beginning to scratch the surface on how to work with marine mammal stranding groups to get data that is so hard for them to collate in these databases, get us especially in real time. So like, for instance, I was going to make the point that in 2022, most of the animals stranded in Santa Barbara, but we were never really able to get all of those numbers because it is a challenge. People, as you know, Alyssa, you can attest to, you guys are working in real time, getting all this information. The idea that you're then going to be beholden to getting all that information to a group like SCOOS so that we can plot it up in a talk is kind of crazy, because there's just too many pressures on you. But we really do want to get here, and I know that the stranding network in California along the West Coast has this goal of digitizing data. Can we start to have standards that allow this kind of communication? But for now, this is what we've been able to collate some of these numbers, and you can see the last 4 years. You can't see 2022 as well, but you really can see that in 23 and 25, we had the largest number of strandings. But it doesn't mean that 2024 wasn't important. It was also a very important year. And if you just think back to the people who were on the ground and how much work had to be done in the media requests, you would know. And it's not really, I would say that's not reflected here in this plot. But the other thing I want to bring up, and I think we can get back to this maybe in discussion, is that not only are we seeing a lot of animals, but we're seeing some abnormal behavior. And this is new. As far as I'm concerned, this is new. And I think we could debate whether these encounters, or some people would call them attacks. I know we want to avoid some of that language, but some people would debate how frequent that happened in the past. But I will say that since 23, it's been happening in abundance. And I don't have exact numbers for that. I don't know if anyone here actually has been recording those exact numbers of people who have either reported attacks or come to the hospital with bites. But there's something happening. It's erratic, it's aberrant, and it's connected to domoic acid exposure. So I'd like to talk with you all more about that as we get to the end and think about I know we've had a lot of great discussions about whether this is just chronic exposure. You look at how these animals are getting hammered one year after another. Is there just some sort of threshold that's been crossed? And we're just going to see more and more of this. But getting back to appreciating just what kind of sentinels these California sea lions are, I think we've talked about this for years. And I don't want to say that all of this is just sea lions. We know that lately we've been dealing with a lot more cetaceans. And that has been one of the other hallmarks, I would say, of the last 4 years that's different, is just how many dolphins have come in, and then even in more recent years, especially this last year, larger cetaceans. But thinking about the fact that with every one of these events, we probably would not have known something was happened, for the most part. 2025 is different. We wouldn't have known something was happening if it weren't for the animals coming in first. So we have this great shore station monitoring program, but it doesn't always capture the blooms, and certainly not always at the very earliest stage of the bloom, where often it's an offshore initiation. So in 2022, it's pretty obvious that we hardly caught it at all. Wouldn't have even probably known there was a domoic acid event if it weren't for the animals. Same in 24, it was a bit lagged. Eventually we did see some domoic acid. But in 23 and in 25, we really did see a very large expression of both pseudonychia and domoic acid at the shore stations. And what made 2025 different was that this bloom really started at Scripps Pier and even further south in Baja on basically around Christmas Eve of 2024. And upon talking to our colleagues in Baja, it turns out at CSSA said, yeah, of course, these animals were coming in. We had a lot of domoic acid in December. And then we started to see it really pick up again here in January. When did the animals start stranding? Not until late February is when we started to get that first big pulse in the Santa Barbara Channel. So we had an early warning. Could any of us have predicted how it would manifest in the food web? No, because we do not have that kind of capacity yet. But this ultimately was a bloom that started in the south and moved north. And it moved north seemingly in lockstep with the sort of La Nina Kelvin wave that was being propagated with this year's La Nina. And you can really see that in the imaging flow cytobot data. It's a beautiful data set for this sort of purpose, where you've got Scripps, Del Mar right offshore, Stearns Wharf in Santa Barbara, and then Santa Cruz. And what you're seeing is just the classifier for pseudonychia. It's not really pulling out necessarily seriata, size class from delicatissima, which would be like the more non-toxigenic versus toxigenic. But what you're seeing is that this bloom really did move. Now, are the conditions just changing? This is not, in the way I interpret this, this is not that the bloom is moving, it's that the conditions for bloom development are moving up the coast. And ultimately, this went as far as Bodega. There were moments during this period where, from through all the way to May of this year, that we saw a lot of pseudonychia and even domoic acid all the way up to Bodega Bay. So this is like most of these events, and what I think makes them so hard and so different from a lot of harmful algal blooms in the country, these are things that span hundreds of kilometers offshore and sometimes thousands of kilometers in latitudinal space. So the idea that we could, control them is crazy. I mean, people talk about it, but we can't really control these blooms once they've happened. But I think we can't even just put one attributing factor to the origin of them outside of, say, some sort of major oceanographic event that's stimulating a lot of this to happen. And we can talk a lot about what all of that is and what all those factors are. But we're still going to focus on what makes all this recent stuff anomalous. And one of those things is that the domoic acid we were measuring, and in most of these events, we were able to get NOAA and cost event response money to get out there and do offshore surveys, do subsurface surveys, find out how high things were. And in fact, in 2022, when we saw nothing at the shore, we saw really high levels of domoic acid offshore in the Santa Barbara Channel, and probably the maximum were at 30 meters. So that just gives you a flavor of how hard it is to detect this domoic acid from most standard monitoring systems. But it wasn't the highest DA we've ever seen by any stretch. And I don't think it has been in the last 4 years, at least in terms of what's particulate in the cells. But what is different is how much is in the tissue of the animals. It appears that we're breaking records. So a lot of these data come from Rafe's lab, Kathy Lefay, Michelle. And we don't have recent years because it's been harder and harder to deploy resources to do this. These are snapshots, but I think they're important snapshots to point out that in the particular case of these sea lions that were processed and this dolphin case, these are really, really high levels of loads of DA in the tissue. Why are they higher than what we think we've seen in the past? when the domoic acid production is not necessarily higher in the cells. This, to me, speaks volumes to the food web transfer, the efficiency of domoic acid transfer in the food web. Are these longer food webs, shorter food webs? How do you get to this kind of level of tissue? Are they just eating more? Is it little, I'm not going to get into this today, but we're thinking a lot about this, and how do we look back at anchovy and sardine landings and Cal coffee data to understand the variability in forage fish in relation to the variability in strandings of these animals and their tissue loads. So then, when you have this kind of information and you want to ensure that the community, the research community and the public are informed, because we are one of these kinds of boundary organizations, it definitely falls on SCOOS to do a lot of this work. We've gotten better over the years. The graphics are really improving. And the goal for us is to provide this kind of situational awareness for our partners, primarily in cases like this. It's the first responders dealing with these animals. It's also the California Department of Public Health. And so if we're going to continue on the thread of things that are anomalous, what I haven't mentioned is that we also had a massive Alexandrian bloom on top of the Pseudonychia bloom this year. Very strange, fairly anomalous in terms of the cell abundances of this organism that I'm sure you're all aware is impacting marine mammals in other places, particularly in the Bering Sea. And so saxitoxin was being measured pretty high at our shore stations, such that we had a prolonged shellfish advisory for saxitoxin in Southern California. This is very unusual, and many of the animals that have so far been tested by Kathy's lab have shown positive saxitoxin in the tissue. I don't know how rare that is. I think it would be great to talk about that. To me, this seems new, and I think we should be talking about the fact that this could be a new place to go in terms of thinking about the dual toxin loads on these animals and the impact of those toxins together, and maybe even what that means for some of the behavioral changes that we've seen. Because saxitoxin is a nasty toxin, and it's the only one that's ever killed a human in California, and it behooves us to get that information out to the public, because there's a lot of people who recreationally fish and may not know anything about the advisories that are coming out of the biotoxin program at CDPH. But on top of that, we have now a new potential cyst bed of Alexandrium that we may never have had in California before, certainly not in Southern California, which means we could be seeing more of this, and I just want to put that on everybody's radar. In addition to the kind of real-time documentation and information and graphics that we were trying to push out to all of our partners and the media and the public, we do also produce a retrospective bulletin. It's kind of become bi-monthly recently because we want to make sure we have as much correct data as we can put together. But the goal of this, and it's really different from some of the other HAB bulletins you might know of, if you know about the Pacific Northwest one, that one itself is trying to be a forecast. We have Sea Harm, that's kind of our forecast product. But what we do is go backwards and try to do the post-mortem, if you will, on the event, and do this in a rigorous way so that we're collating all of the different information, whether it's our own monitoring, the California Department of Public Health plankton and DA monitoring, the model itself, IFCBs, marine mammal stranding numbers that we can get together. They all tell a different story. And I think this is, again, why oceanography and all of this kind of biology is so difficult. The complexity is insane. What a shore station tells you versus what the animals are telling us versus what the model is telling us, they can be very mismatched in time and space, but they all tell us something critically unique and different. And I think it's a good exercise. And one of the things for me, I think that motivated this was when we were putting out a model like Sea Harm, it's hard to tell people, is 60% probability a threshold? What is a threshold of concern? How do you read a map like that and make any sense out of it? But I think that if you are a shellfish grower versus someone who cares about the sea lion population, your perspective on what percent threshold matters in a model like this is going to vary considerably. And so in order to kind of personally calibrate that, you need this kind of retrospective, and you need it to be frequent enough that you can put together the skill in your own mind, because we all know which kinds of skill the weather forecasts have that we want. I mean, I always take an umbrella at 10% because I'm high maintenance and I know which forecast I'm going to need that for. It depends on your risk level for all of these things, right? And so I don't have time, nor have we done the analysis yet, but I've got to give you some long-term perspective about what's making some of these years different. It'll be a bit of a bottom-up perspective right now because I don't have all the food web data at the moment. But I think in the next 6 months, we're working with kind of a dream team. It's kind of the Elliott type crew you saw earlier. We've got a lot of people from Southwest Fisheries engaged in this now to ask the question. We have data sets going back to the 80s from Cal Coffee. We can look at this stuff in sort of a deep time perspective and see what's changing. We know there are dramatic changes happening in the nutrients that are the source waters to upwelling, that are coming from the California undercurrent. There are changes. We see that in the Cal Coffee data set. I'm not showing those here today. I'm just showing you our nearshore nutrients. Just looking at that, you're just kind of like, okay, it's a lot of squiggly lines, mostly dominated by Cal Poly and purple here. I'm not showing you the whole coast. But you can see some pretty dramatic trends, particularly if you dive into the silicic acid part of this and the Si to N. So silicic acid is what the diatoms need to create their frustules. There are patterns here. A lot of them connect to La Nina. I don't want to burst any bubbles over anyone who thinks El Nino is the main driver. You honestly statistically can't connect any of this perfectly to any one thing. Depending on the time series that we looked at and published over the years, it'd been like, it's PDO, it's NPGO. No, it's actually ENSO. No, and so it just depends on the chunk you take and the stats you do. You can get one of those answers for everything. We're traumatized by the 97, 98 El Nino for sure. And we think that that's kind of like set the stage for everything, but I'm not sure it did. And I think these La Ninas are also really critical because of the intense nutrients that come up with them. And if you have a La Nina year followed by lots of punctuated warm periods, you can have a perfect situation for a bloom because you fuel it. This is what happened during the Pacific Warm Anomaly, during the blob. Warm heat wave, lots of upwelling in a 50-kilometer stretch along the coast. You get this going, you heat, rinse and repeat. You get sort of a 5-month-long bloom out of that. So we're not showing you a lot of stats here yet. I think this is just an amuse-bouche to get you to think about the fact that we have to be looking at the bottom up as much as we do the top down. And if we look at those two things in relation to particulate domoic acid, yeah, maybe there's something around La Nina, but I want to point out one of the reasons we started thinking about this, because I kept thinking about when I was, looking at postdoc, looking at 2010, 2011, some of the highest DA I've ever seen in my career. Never saw, as far as I know, any marine mammal impacts, or even seabirds. Why? Well, talking to Cal Coffee folks, the anchovy and sardine populations had tanked that year. Is that the missing piece to understanding this? The last 4 years, we were in some of the highest anchovy returns we've ever seen. Is that what explains what we're seeing? I don't know. TBD. But I think these are the kinds of things as a community we need to come together and ask to understand some of this variability. I think that's it. I just have a little summary here to say that we're trying to work a lot with our partners more than ever before on the marine mammal side. The utility, there's just so much utility there and importance we'll probably never be able to save these animals. I hate to say that, but the awareness I think is critical. And then these recent events, I think we all believe they're anomalous. We just need to figure out why. And we're going to use SCOOS and Cal Coffee and other long-term databases to try to get at that. And I would love all of your help. Thank you so much for your time.
Thank you, Clarissa. That was amazing. Just fascinating and daunting and terrifying all at once. But we can take some questions because we're at the end of our program. So Sue, okay.
All right.
Great presentation, or amuse-bouche, however you want to think of it. I like the food analogy because drawing in the sardines or anchovies or choose your forage fish, I'm wondering how, though, you think the Cal Coffee data set, which I think is amazing also, how will that serve you in space and time in terms of a sampling grid? I guess just your thoughts on how you're going to draw this information out in the next
Yeah, we're still in the early stages. We've had these kind of dream team meetings, right? I feel like it's a dream team of people who can look at this. And because Stephen Bograd has already been doing this for quite some time with the biogeochemical component of the Cal Coffee data set, largely unappreciated component of that data set, and he's really shown that these trends, particularly in Si to N, have actually gone down linearly in time with the Cal Coffee data set. And as many of you know, to me, Si to N is the driver for domoic acid production. So there's something there. Now we have this beautiful scale. Cal Coffee is actually sampling within the California undercurrent. So that's amazing in terms of vertical spatial scale. And then just in terms of that horizontal spatial scale, we're really able to look at these sorts of ichthyoplankton and then other fish returns for that entire swath of the California current that it covers, which is kind of critical. We couldn't do this with any of our nearshore data sets. So just, the core of your question is, how is this going to help us? We don't have a perfect plan, but it can't not help us.
No, it gives you a great foundation, I think.
I think so too.
Yeah.
But we don't want this paper to be, pretty much every harmful algal bloom paper usually is, unless we're describing what's happening in the animals, we're talking about the blooms in terms of bottom-up forcing. I know I fall prey to that. That's how I think of blooms. I'm rarely thinking about the interaction with the rest of the food web. But it's time we do that, given how much California has the richest data sets of these like this in the world, right? Yeah.
Thank you. Francis?
So you talked a lot about the food web, and yet most of what we know is still really about sea lions eating anchovies and sardines. We've got this one model.
Right.
That coastal, they come ashore when they have seizures, they eat things that we can sample. And yet we have all these other marine mammals, and we heard today about gray whales, for example. So I've always been pondering, how do we get at what is a gray whale exposed to? If it's feeding stuff on the benthos, stuff further out, stuff in places where they're not supposed to feed. We know they're supposed to feed here, but they actually feed there.
Yeah.
And then we've also heard a lot about new technologies. And so in your mind, do you think there's a possibility we'll get to like a flow bot that we could drop from a drone onto a whale's back and it could go along and sample what the whale's eating? I mean, how far?
Yeah, that's pretty far out. I think, let's do it.
But, so somewhere between the flow bot on the back of the gray whale and the sea lions on the beach that are seizuring dead, there's a lot of other stuff that we could be sampling. And how do we get more towards that, like further offshore, different parts of the food web?
And I might be Pollyanna about the power of stabilized chips, but I think they're very useful. And I think we have been able to extract some new information from the compound-specific amino acid work. I think it can get you a lot of information that you wouldn't get otherwise. Alyssa will probably laugh because we have a whole squid paper we're working on where the sea lions who came to shore, a patch of juvenile males, which is loaded with squids in their guts. We know they're shifting more to squid depending on, what's happening out there. It did look like it could have been a DA event. It's hard to say for sure, but there was DA in there. Squid is one of those things where I often wonder, when we look at a lot of dolphin strandings, is it more squid than anchovy? I don't know. Again, I don't know anything about these animals. It's quite painful, actually, how ignorant I am. But I think that if we work together and talk about what we think they're eating, then we can start to piece that together. And that is where the stabilized work has been really helpful for us, because we can not only see the length of the food chains, we can start to connect the signatures in certain prey to the dominant signature in the animals that are feeding on them. But I mean, it's a great question that I don't have an answer to, but we need to know more about that, because you're right, it's kind of been anchovy. We have one model. We did have a sardine closure this year, a commercial sardine. In addition, we didn't have an anchovy closure because I think most of those get exported, but the sardines not necessarily. And so the sardine closure was in direct response to domoic acid also. And I've never seen that in my career. I don't know if you have. Never.
Tuna, dead penguins in zoos that ate sardines that came past presidents of the United States with memory problems after having eaten Monterey.
I mean, anchovy are more efficient vector, but yeah.
Are there any other questions? Thank you for those good ones. Oh, sir. Oh, yes. Go ahead.
Do you have any evidence how far when they come in, they're in pretty awful shape. So is there any sense for how far offshore you're sampling from when you see these guys coming in?
You mean how far offshore are the animals foraging?
Yeah, when they got sick, how far offshore were they that they could get to shore as opposed to dying out in the ocean?
Yeah. No, we've tried to look at that through the data. It's really tough. I don't know. Alyssa, do you want to take a...
Actually, Clarissa, could you repeat the question just for...
Oh, yeah, sorry. So the question is, when an animal comes in, how far offshore do we think it acquired the domoic acid, such that it was able to get to shore to strand in the first place?
I don't know if we can answer that, but I will say that this bloom this year in particular, we saw way more common dolphins than we're used to seeing with blooms off our coast.
Yeah.
And they seem to pass away super quick when they hit the beach. So that would give me the indication that at least with this year, maybe the bloom was a little bit more coastally associated, but they do tend to forage throughout the Southern California bight. They'll have a little seizure, they'll wake up, maybe they're floating in. So it's really hard to tell at what point they really hit the beach. But this year in particular, it was really hard to pull them out of having seizures. And we don't know if that was a dose response to the level of toxins or the repeated exposures from year to year.
And it's important to think about the habitat compression work that Elliot was discussing, because we have seen so many cetaceans in the last few years, which is a really different thing. And we know that since the Pacific warm anomaly, the anchovy have been coming closer to the shore, the cetaceans are following. So how much of that plays a role too?
Yeah, go ahead, Francis.
From your perspective as director of SCOOS, and then working on presenting the data to the public, and you're obviously well aware of the challenges the Stranding Network members face in just their day-to-day work and managing data. So what would be the sort of ideal level of data and speed of delivery to SCOOS that in an ideal world you'd like to see as director of SCOOS and coming from your perfectly funded and responsive Stranding Network?
Well, it's fairly crude, really, because I think in order to deliver information on the magnitude of an event, we do just want to know kind of the best guessed DA suspected animals coming in and get that information out. And I fully respect that we don't want those to become the published numbers. It takes a lot of work to then verify all of that. And I think ultimately we should be publishing those verified numbers. But for me, it's pretty basic. What do we call it? Level 1, I think level A. You call it level A, right? Level A metrics that we really need on our end to convey what we need to convey. Once you start getting into the weeds about the conditions of these animals, it's not something that I think we can put out in the right bits and bytes that gets to the people, that tells them the clear story that they need about domoic acid in these animals. And then also trying to, I think it's been a struggle for me to convey the stuff about the aggression, in part because we have all this stuff at La Jolla Cove going on, which just muddies the water incredibly. Yeah.
Okay.
But thank you.
Thank you again, Clarissa, and a round of applause for all our great speakers. Yeah, I'll let Peter wrap up our wonderful session this morning.
Okay. We're sort of going to accelerate our ending of the program, just to give everyone fair warning. We had said we were going to go till 12:30. I think we've gotten through our talks. And one of the things that encouraged us to do this was Karen's fantastic summary at the beginning of this session of where we'd gotten so far in the meeting. And then the subjects we've covered since then have touched on new innovative technologies, but have been more California focused. So I think we're going to put Sue off the hook. She somehow got on the agenda. We're not actually totally positive how that happened, but it's just basically because we figured Sue would have something to say.
I think I stepped out of the room or something, man.
Yeah,
Anyway.
that's right. There was a meeting you weren't at. We said, okay, Sue can do that. But again, Karen, thank you so much. It takes time during the middle of a meeting to do that kind of synthesis, and I can never do it. So having you do it was perfect. And just, I mean, people who've been to historic Marine Mammal Commission meetings have seen that sometimes we've had almost 4-hour wrap-ups of a 3-day meeting that I think some people found maybe a little much. But in that regard, we will be, as we've said before, we're recording the meeting. We'll be putting the recordings of the meetings, and I guess some sort of synopses of the sessions. I can't remember what we're doing exactly on that, but you can come to our website and find the meeting. If you missed a session, you'll be able to find the details of what was talked about at that session. yeah, so over the next few weeks, we will be putting that up on our website. We'll be sort of synthesizing in our brains what happened. We'll probably have some get-togethers to say, okay, well, you know, what were your takeaways from the meeting amongst our group? Then, and also on our schedule is an opportunity for public comments. We'll open the floor for that, just general comments, which we will record. We're not necessarily going to respond to such comments, just it is a public meeting. So if there's anyone who's been planning to talk to us about that. Brady, you look like you're poised at the mic.
Yeah, I'm just going to say that for those online, if you put your comments to the commission in the chat, those will be recorded and archived as a part of this meeting. And for those in the room, I do have a mic I can pass around. If somebody raises your hand, I'll walk it over to you.
Yeah. But I'm going to actually sort of more formally close the meeting right now, if that's okay, just to really particularly thank the staff for putting together a fantastic meeting, both in substance and in logistics. The logistics are just as much work as the substance, but we had to develop the agenda, clear it with the commissioners and our scientific advisors, then reach out to speakers. We've had incredible speakers, really appreciate the work done by the speakers and the coordinators of each session to make the sessions come together. It's a good opportunity to thank our Committee of Scientific Advisors who are experts in the field of marine mammalogy, but a variety of expertise in a variety of regions for a variety of species and a variety of more substantive specialties. We use you to help us as we develop formal recommendations to the agencies on different permitting regulatory actions. We also use you to help us in this kind of, how should we talk about things? How should we talk about the substance of issues? Again, whether it's in a region or whether it's, as we say here, on new technologies. You're spread all around. I know our communications are kind of erratic, but we really value your input, and thank you. And if you have input for us as a staff and commissioners on, how to do better, but also issues that we ought to be looking at, definitely tell us. But again, I can't express our appreciation enough for you out there in the wilderness while we're stuck in Washington. Oh, no. While we're more centrally located. And then, again, thanks to the commissioners who lead us every day for their work. And I think I'll just mention, once we're done with any public comments, it might be good for the staff and the commissioners and scientific advisors sort of just huddle a little bit, sort of say, okay, what are we up to? What's our schedule going forward on things? That might be good, sort of the information and logistical side. Sue.
See, it turns out I want to say something after all.
Oh,
and that is, I want to thank you, Peter, for your leadership in the centrally located area. And Francis, I mean, you both provide such strong and consistent leadership. I want to thank the CSA. I'm happy to have met some of you here for the first time, others I've known longer. Karen, that really was a masterful beginning for today because you were able to weave together your experience in the California current, your long experience on ships and planes, but see the value of these new technologies that are coming forward, and it is exciting to think how they can fit in. But again, thanks to you, Peter, thanks to you, Francis, because your leadership, along with Lori and others and the staff, that's the commission, and we're in challenging times, and so to pull this off in challenging times is really important.
Thanks, Sue. Okay, and with that, I won't do anything else. Thank you, Sue. And we'll basically close the substantive part of our meeting. Just check in to see if anyone wishes to make a public comment for the record. Obviously, we're not a regulatory meeting or anything like that, but we'd really appreciate your comment. So I guess say your name and who you are, and then we'll be recording what you say.
My name is Jim Bishop. I was privileged in the 1980s to be introduced to the Marine Mammal Commission and actually work under contract for the commission on the California Sea Otter project back then. And I've somewhat time warped my participation in an annual meeting. It's been a long time. I do read the reports periodically, but I think the independence of this commission is highly important in terms of how you all look at the actual science of the challenges that we're facing. And I think that the continuation of the commission is so important to the future of our country and marine mammal populations. I just wanted to emphasize that and say again today that it's really a privilege to be here.
Thanks so much. Yeah, thanks, Brady. If you have comments online, let us sort of know the content, and maybe we'll be able to wrap up early. I would say if there's anyone online, well, I don't know. I mean, I'm not assuming people will be showing up at 12 just for this privilege to speak, but if anyone does, we'll accommodate that.
Yeah, I think if folks pop on early or later, we can always accept things in our email inbox. This comment is online, so and I think it's the main one we've got since we opened it. So excuse my reading. Good morning, my name is Francine Kershaw, and I'm commenting on behalf of the Natural Resources Defense Council and the Animal Welfare Institute. We'd like to start by thanking all the speakers for their excellent presentations during the meeting. Thank you for highlighting the recent changes in the eastern North Pacific gray whale population. Our groups are extremely concerned about the population's steep decline of more than 50% over the past 9 years, as well as the continued evidence of a depressed reproductive rate and the ongoing climate change, ocean warming impacts in the Arctic that calls into question the population's ability to recover. We agree that there is an urgent need for scientific community to come together to review and discuss the latest scientific understanding of the status of the population and the causes behind its decline. NRDC and AWI are therefore in strong support of an international independent scientific workshop that establishes the scientific baseline of understanding of the population as it stands today, including its population structure, considers the future prognosis for the population considering climate change, ocean warming, and the species' energetic requirements, and explores management alternatives to maximize population resilience in the face of rapid environmental change. Our groups stand ready to support the realization of such a workshop in whatever way may be most helpful. And the other comment that just came in, thank you to the MMC for organizing and hosting this meeting and providing an option for the public to participate remotely on gray whales. The current ENP gray whale SAR is well out of date, so NOAA NIMS is strongly encouraged to expedite the preparation of a revised draft SAR for this stock. Thank you, DJ Schubert, Animal Welfare Institute. And with that, those are all the ones that have come in.
Okay, thanks for those comments. Again, we'll kind of keep track if there are folks, I assume folks are there listening. If someone were to come on at noon, we'll welcome the chance to hear from them. But I think in terms of just wrapping up our work here, we will wrap up our work here right now. And again, thanks to everybody, and have a safe trip home. Maybe after 10 minutes or so, let's just check in with our staff and CSA on logistical stuff and where we're sort of our time frames going ahead. So yeah, just come on back in here and that won't take long. Thanks, everybody.